In this tutorial I'm going to show you how to use AutoCAD to extract data from SEM images like these ones. These are the four examples I'm going to use. Here I'm using lines to extract data from gallium arsenide nanowires. Here I'm using circles to extract data on these nanodots. Here I'm using a polyline tool to extract data on the area of a sheet of graphene, and here I'm using the ellipse tool to extract data on these elliptical nanodots. So I'm going to make a new drawing to get started. Just click on this plus here and click Start Drawing to get a blank template. So to insert an image, I go to Insert and Attach, and I'm going to select one of these files here. Now I'm going to leave insertion point ticked so I can specify where I want to put it on the screen. I'm going to leave scale unticked because I'm going to specify the scale later on. I'm going to leave rotation unticked because I just want it to be horizontal like it is. So I hit OK and pop it down wherever I want. So I'm going to zoom in here using the scroll wheel on the mouse, and you can also pan around by holding down the scroll wheel. And to scale this image, what I'm going to do is I'm going to draw a line along the scale bar and then scale that and the image until the line is 4,000 units long. So I'm going to zoom right into the end of this and start drawing a line like so. So I go to the end of the scale bar, and I go to Home, and I select Line, and I click here right near the very end. So right now the line is coming out at it can be any angle at all, but I want to draw a perfectly horizontal line. So to toggle between drawing lines at any angle and perfectly horizontal or vertical, you hit F8, and now I can only draw along the X and Y axis. And hitting F8, the function that you're toggling when you do that is called ortho. So you see that it says ortho down here in the command line. So I go right across the other end of the scale bar, zoom all the way in, and I click at the middle of that. And to exit the line command, I just hit spacebar. So now I've drawn a line the length of the scale bar. So I want to scale the line and the image now. So to do that, I use the scale command, which I can access here in the ribbon, or I can just type SC into command line to do that as well. So I type SC and space. So now I have this square box instead of the drawing tool that I had earlier on. So I select the objects that I want, which is the image and the line over the scale bar. And to tell the program that I finished selecting objects, I can hit either space or right click. So I just hit space, and then I'm done. So now it asks me to specify the base point from which everything's going to scale. It doesn't really matter where you choose. I'm going to pick the end of the scale bar like so. And then the command line is telling me to specify the scale factor or copy reference. So you'd only specify the scale factor by putting in a number if you knew exactly how many times bigger or smaller the image is supposed to be. But more often than not, you're not going to know that, and for that reason, you're going to use reference. And to select any of the sub options within a command line function, you type in whatever letter is in blue. So to access reference here, I'm going to hit R for reference and space. Now to finish the scale command, there's basically two steps. The first is to specify the old length of the scale bar, and the second step is to specify the new length of the scale bar. So to specify the old length of the scale bar, you just click both ends of it. So I click the first end and the second end. And to specify the new length, you just type it in. So I'm going to make it 4,000 units long so that the scale bar is 4,000 nanometers long. So 4000 space. Now I can zoom out by using the scroll wheel, but sometimes a faster way is just to type Z space E space. So by doing this, what you're doing is you're going into the zoom function, and then you're selecting extents within that. So you're using zoom extent. So Z space E space, and it brings it right back out to the limits of the drawing. So now I'm ready to start drawing lines over this image. So to do that, I click on the line button up here in the command line, and I click on the start and end of a couple of gallium arsenide nanowires. And at the end of each line, I'm using spacebar to escape the line command, and hitting spacebar again also repeats the previous command. So by double spacing, you're both exiting and starting the line command again. So I've drawn about 6 or 7 lines there, and that's probably just enough for demonstration purposes. So now I'm ready to extract data from those lines. So to do that, to access the extract data tool, I go to Insert, Extract Data. And then this command, I have to save the drawing before I do that, so let's just save it with some kind of name like wires1. Okay, so now this command window pops up, and there's a couple of options here. It says create a new data extraction or edit an existing data extraction. So I have to go through this option here, and there's a couple of steps in it, but once you have it done the first time, it becomes a lot faster. So it asks you to save a name for the data extraction profile that you're doing, so I'm just going to call it wires. Enter, and then there's a couple of different options here. I'm going to select the objects in the drawing that I want to extract using that button there, and I'm just going to select those couple of wires. It actually doesn't matter if you select the image as well, so I'll just do that and show you why, and then you hit space to tell it that you finished selecting objects. So you go to next, And the reason I said it doesn't matter if you select the image as well is that it appears as an option in the data that you're going to extract. So I'm going to untick the image, leaving only the lines for the remainder of this function. So I hit next, and then this is a list of all the different data that you can extract about those wires, so or about those lines. So there's an awful lot. I'm just going to untick some of the categories, leaving me only with geometry to speed things up. And there's a lot of different things there. All I want is the length, so I can click the first, and then holding down Shift, click the last, and untick them all, and then I can just take the length. So I'm only extracting the length data, and then I hit next. Now there's this is what the data out is going to look like. I don't actually want a count of different things. I don't want the name of a line, so I'm going to untick those options there, leaving only the actual length data. So I hit next. I'm going to output the data to an external file. I'm going to give it a name. Let's call it wires1.txt, and hit next. Let me just see where I'm putting it. I'm going to put it in a specific folder here. AutoCAD data extraction wires1.txt. Perfect. Save, next, and finish. And so now my that file should be in this folder over here. So here it is, wires1, and I can see all my data there in a notepad file. So I'm going to close this and do another example. I'm going to move over here and attach the dots image using the same options as before. Hit OK and drop it on the screen. I'm going to zoom in, and again I'm going to draw a line from one end of the scale bar to the other. So I type L space, zoom right in here to click the first point, and zoom all the way over there to draw the second point, like so, and space to exit that command. Then SC to scale it, select both the image and the line, click the end of the scale bar as being the base point for the scale. I hit R in space for reference, and then I click each end of the scale bar for the reference length, and then type in 500 for the new length of the scale bar. So I scale my image. And now I want to draw a load of circles over all of these nanodots. So I go to Home and Circle, but the default setting for circle is to specify the center and the radius, and it can be a bit hard in this case to know exactly where the center is. So there's another option within circle called 2 point, and using that you can click 1 point of the circumference and then somewhere on the opposite side of the circle. So that's a bit easier, and after you use it the first time, the default command changes to the 2 point. So that makes it a bit faster for drawing a bunch of circles. So I'll just draw 4 or 5 and then use the extract data tool. Okay, that's enough. So I go to Insert, Extract Data. I'm going to create a new data extraction again. I'm going to call it circles this time. Save, select the objects in the drawing. I'll just select those 5 circles and space, and then next. I'm just taking the circles. The image isn't in this option here because I didn't select it in the previous step. I hit next. Again, I only want one of the options under geometry, so I unselect all the other commands, and I unselect them all using Shift. And then let's just go for diameter. I'm taking that option and hit next. Again, I don't want the count or the name, so I untick those options, leaving on the diameters, and hit next. Output data to an external file again. I'm going to put it in the same folder. Let's see where that is. I'm going to call it circles1.txt. So again, if I look in my folder, I have to hit next and finish, and then in my folder I should have my circles data. There it is. So with this circles data and the line and the wires data, you can just copy and paste this data directly into Excel and do lots of analysis on it there. I'll do one more example. This one is of the graphene sheets using the polyline tool. So I'll just go to Insert, Attach this graphene image, and Open. OK, and drop it on the screen. Again, I'm going to draw a line each end of the scale bar to specify the old length of the scale bar, like so. That's good enough. And then I use the scale command again, selecting the image and the line over the scale bar. Space to finish selecting objects. I'm going to specify this end as the base point, and use the reference option again. Specify the old length of the scale bar by clicking each end, and the new length of the scale bar by typing it in. Again, it's 500 and space. So now my image of this graphene flake is scaled. Now to define the boundaries of this graphene flake, rather than using the line command, I'm going to use a different command called polyline. And polyline is a bit like line, except that all of the different segments are a single object, and that way the polyline also has circumference and area properties to it as well as length. So I'm going to click here, and I'm going to turn ortho off at this stage because I'm not drawing along the x and y axis by hitting F8. And I'm going to quickly draw the outline of this graphene flake like so. Almost there. Okay, and then space to finish. So there's a couple of different ways of doing this. I can extract data again using insert and extract data. If you just want to do a quick inquiry about this thing, there's a couple of ways of doing that. You can select the object and type li for list, and this window pops up which tells you pretty much all that you might want to know about the object you've selected. So here it tells you the area in square nanometers, and also tells you the length there, so that's the circumference of that polyline. But let's just say that you had hundreds of these shapes all over your image, and you wanted to go to the extract data process. So you would hit extract data, create a new data extraction. I'm going to call it area, save, select the objects. There's only one. Next, it's a polyline, so there's nothing else to untick here. And I'm going to take out everything except for geometry, and I just want the area, so I'll untick those two and hit next. So I'll get rid of the count and name again, so this is the only data that's going to be coming out. And next, I'll put the data to, let's put it in here again, and call it area 1. Save, next, and finish. And sure enough, in my folder I have area 1 with that data. I'll do one final example with the elliptical nanodots, so I'll close that and insert that image. So it's insert, attach, and this time it's the ellipses file. And I'm going to drop it down on screen. Now I'll scale that again by drawing a line each from one end of the scale bar to the other. I'll turn on ortho again by hitting F8 so I can draw a horizontal line like so, and then scale again by SC and space, select the image and the line, specify the base point, just one end of the scale bar, using the reference option by typing R and space, specifying the old length of the scale bar by clicking each end, and the new length of the scale bar by typing in the length of it, so it's 200, 200 space. So now it's scaled. So in this case I actually have to rotate the image. So I'm going to use a procedure similar to what I did before. I'm going to draw a line and rotate the image and the line in the same way that I drew a line and scaled the image and the line for scale. So it's going to be pretty similar. So I'm going to draw a line along one of these chains. I'm going to turn off ortho there by hitting F8 and space to finish drawing the line. So I'm going to rotate the image and the line by typing in RO for rotate, or you can also access that on the ribbon here by hitting the rotate button. So let's just do that. Select both the image and the line, and you'll see there's a lot of similarities with the scale option here. Hit space to finish selecting objects, specify the base point, which will be the end of the line. Again, there's rotation angle or copy reference. I'm going to use the reference option again by hitting R space, and the reference angle is the angle of the line, and the new angle is just going to be a horizontal. So and to get it perfectly horizontal, I'm going to turn on ortho and just click somewhere over there. So now my image is rotated, and all the nanodots are along the horizontal. So I'm going to delete this line by hitting delete, and I'm going to start drawing some ellipses. Now the option to draw ellipses is somewhere up here, but I think it's handier just to remember the command line, which is just ELL for ellipse and space. So to draw an ellipse, you specify each axis endpoint and then the minor axis. So I'm going to turn off ortho to do this because they're not all perfectly along the x-axis. So I'm going to click there, and then the minor axis, there, and the minor axis, there, and there. So I'm just going to draw 5 or 6 ellipses like this. Take a cue from this line. And that should be enough. So I'm just going to go to extract the data now by going to insert, extract data. I'm going to create a new data extraction again, hit next. I'm going to call this one ellipses, hit save, select the objects in the drawing I'm going to extract, those 6 ellipses, and then hit next. Only ellipses are available to choose from because they're the only things I selected. Hit next again. I'm going to unselect all of the options except for geometry, and let's just say I want to get the major axis and the minor axis. So let's look for those. There's the minor radius, oops, and the major radius. Okay, and then hit next. I'm going to get rid of count and name, and so this is what the text file is going to look like. It's going to have 2 columns, one for radius, one for major radius and one for minor radius. Hit next. output the data to a file. Same thing again. I'm going to put it in this folder and just call it ellipse data. Ellipse data. Next and finish. And then in my folder, I should be able to find that. There it is with 2 columns. So now I'll show you how to extract that data to Excel. And while you could just copy and paste it, there's a nice way of doing it using this from text option here under data. So if I click that, I'll just use the wires line data as an example. I'm going to hit import. Now there's different options here. I'm just going to hit finish because it's fairly straightforward data. There shouldn't be any problems. I hit finish and OK, and sure enough it's fine. And the lengths of the 6 wires that I wanted are there. So I'm just going to quickly make some bins between 2000 nanometers and 2700 nanometers. And I'm going to make very quickly a histogram of this data. So if I select those boxes there, I hit equals frequency, U-E-N-C-Y. The first argument is the data itself, and the second argument is the bins. I close the bracket and then I hit Control-Shift-Enter, so I quickly have my my histogram data, so I can insert a bar chart and get it straight away. So there's only one of each. But the advantage of inserting the data, not copying and pasting it, but from the file, is that you can go back to the AutoCAD image and add new data to it and update the file. So I'll just show you that very quickly. I'll just draw some extra lines here. There's 1, 2, 3 extra data points now. So I go to the extract data function again, and this time I can use an existing data extraction because I've already gone to the trouble of making it. And you'll see that's a lot faster this time. So I choose the wires data extraction file that I made, open, next, and select the objects that I want to extract. And after that, all you have to do is just hit next and finish, and the data file is automatically updated. So if I go back to my Excel document, I can go to data and refresh all, and this will refresh the text file that was used to make this column of data. So I click that and hit import, and you notice that 3 extra data points are added, and my histogram has changed now. These data points have been added there as well. By the way, if you're in your histogram and you want to change the x-axis from just these numbers, you can go to right click, select data, and this option here, you can edit the horizontal axis labels to be the bin labels themselves, like so. Or if you want, you can make a nicer column that's, for example, 2000 to 2099, and then 2100 to 2199 to make the ranges on the x-axis. Okay, just one quick edit is that my SEM image was taken at 45 degrees, so these are not the true lengths of those wires. So let me make an extra column here where I multiply each of those values by the square root of 2 to correct for that. So I'll multiply that by the first column and drag that down. Now I can update my array like so. I'm dragging that over there, Control-Shift-Enter to correct that. And my bins are wrong, so let me just change that from 3000 nanometers in steps of 200 nanometers. And now my histogram is correct.